Hi everybody, we're going to do carboxylic acids and esters nomenclature. So first of all, let's figure out what a carboxylic acid is. So we're going to use C double bond O, bonded to an oxygen, bonded to a hydrogen. And ester is very similar. It's C double bond O, bonded to an oxygen. But this time it's going to be bonded to some kind of carbon chain. So what the heck is a carboxylate ion? Well, it's a C double bond O, bonded to an oxygen, but then that oxygen is not bonded to another atom, and it has 3 lone pairs of electrons, so it has a negative charge. So what are some properties of these things? Well, carboxylic acids have sharp, unpleasant smells. So you're probably familiar with acetic acid, which is IUPAC known as ethanoic acid. It smells like vinegar because it is 5% vinegar solution. Butanoic acid smells like butter, spoiled butter, and hexanoic acid smells like goats. Of course, I'm sure you knew that. Esters, on the other hand, have sweet, pleasant smells. So something called isopentyl acetate smells like bananas, octyl acetate smells like oranges, ethyl butanoate smells like pineapples. So a lot of our fruity smells are esters. So carboxylic acids and esters, we're going to start with carboxylic acids. So part of the functional group for carboxylic acids is called a carboxyl group. So we can write the carboxyl group 3 different ways. The one I wrote on the first slide was C double bond O bonded to an O, which is single bonded to a hydrogen. Same thing here. This C is double bonded to that O, which is single bonded to another O, which is a single bonded to a hydrogen, but you can write it like that, or you can write it like that. So what makes it a carboxylic acid? It's that H right there. That makes it a carboxylic acid. It's called an acidic hydrogen. So how are we going to name them? Well, what you do is you first recognize as the carboxylic acid, find the longest consecutive carbon chain that contains that carboxylic acid. That's going to be your parent alkane. Drop the E from the alkane and add oic acid. So it would be alkanoic acid for generic, but it's more specific when we count the carbons. So carbon 1 is where the acid is. And so that's going to be the beginning of the chain, but we don't put a 1. Why? Because just like aldehydes, it's always a carbon 1, and so it doesn't need a number. I don't know what just happened. I think it stopped and started again. But anyway, you saw the slide already. So we're going to go to this slide, and we're going to name these acids. So you see the COO. Use my pen to write again. Oh, I like that purple. COOH. So we know it's a carboxylic acid, and there's 6 here, so we're going to call it hexanoic acid. Look, 2 words, hexanoic acid. 1, 2, 3, 4. So butanoic acid, but on carbon 3 is the methyl. All right, here we have 1, 2, 3, 4, 5, 6. So we have hexanoic acid, but on carbon 5 is a hydroxy. And then this is benzoic acid. Your benzene ring with the COOH, you should recognize that because we made it in lab from toluene. We oxidized it. This is an amino. You can call it 4-amino, you could call it p-amino, or para-amino. All of those will work. Okay, let's keep going. What if there are 2 carboxylic acids in the same molecule? We're going to call it a dioic acid, and we got to put the E back in. No numbers because it's 1 and whatevs, right? It's on carbon 1 and carbon 7 if it's a hexane, if it's a heptane. All right, so look, it's a 2-carbon carboxylic acid and another carboxylic acid. So we got 2 carbons. We would say ethane, and then di for 2, dioic acid, 2 words, okay? Ethane dioic acid. This one's propane dioic acid. And as usual, I wrote all over it so you can, there we go, now we can see it, right? Okay, so we're back to there. All right, so if there's 2 alcohols in the same molecule, I said alcohols, I meant carboxylic acids. So here we go, this one has 4 carbons, and so we would call it butane dioic, pentane dioic, hexane dioic. Now you might be saying to yourself, well, what if there was a branch? So if there's a branch here, we'll make a methyl there, and we'll make an amino here. Okay, so this would be 1, 2, a 2-methyl pentane dioic acid. This would be, it looks like it's on 6, but we remember from this way, it'd be a 2-amino hexane dioic acid. Okay, other nomenclature rules. If there's a COOH or a carboxylic acid on a ring, we call it a carboxylic acid. So it's always carbon 1. Here's a couple more things. common names. So this molecule would be OH with an H on the side. So we would call it methanoic acid. Methanoic acid. But wait, this is its IUPAC name. You also have to know formic acid for its common name. Okay, so you have to know 2, 4, 1 carbon acid. All right, here is a 2 carbon acid, which we would call eth for 2, and noic acid for the fact that it's an acid. That's IUPAC. And then this is common. So make sure you know those two. Acetic acid is common, ethanoic acid is IUPAC. So here we have a carboxylic acid on a ring. And we have a bromine also on the ring. So we have a cyclohexane carboxylic acid with the bromine on carbon 3. So 3-bromo-cyclohexane carboxylic acid. So that's one of these examples. Here we have a cyclopentene with a carboxylic acid. We don't need to number for the carboxylic acids carbon 1, but 1 to 2 tells you where the pentene is. So 1 for the double bond, cyclopentene, you put the E back in because it's kind of like a dioic, you put the E back in, it's carboxylic acid. Okay, here are 5 more. Okay, these 2 are on a ring, so here's a carboxylic acid, here's a cyclohexane. So it's cyclohexane carboxylic acid. This is a 1, 2, 3 methyl, and it's dash and wedge, so it's trans cyclopentane carboxylic acid because it's on a ring. Okay, these 3 need names, so hopefully you try them. Hit pause, try them, and then see if you got them right. So 1, 2, 3, this is propanoic acid. Okay, 1, 2, 3, 4, 5, pentanoic acid. But wait, there's something on your pentanoic acid. 1, 2, 3, 4 is a 4-methyl. All right, so we have to still use our rules for branches even if we have names. So this way we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6, 7, 8. So this is a methyl and this is an ethyl. So which way do we go? It's a 3, 6 either way. So then the alphabet wins. So it's going to be 3-ethyl, 6-methyl. So here are the names. Hopefully you paused and you did them and then you checked them. Okay. All right, so you don't have to write all this down, but you do have to know these 2. You don't have to know that it came from ants, but that's pretty cool. You don't have to know that vinegar acetum means vinegar or sour in Latin. But here's the common name for acetic acid, 2 carbons, formic acid is 1 carbon. The IUPAC name, it's easy to tell how many carbons it has. So this is 2 carbons, this is 1 carbon. So you have to know the IUPAC and the common name for these ones. The rest of them are just fun. Look at this. This one comes from the word butter, butyric acid. This one comes from to be strong, valeric acid. Must be a strong odor. These 3 come from goats. What? How funny is that? Okay. So, yeah, pretty cool. All right, so if you take the hydrogen off a carboxylic acid, it's not a carboxylic acid anymore. It's called a carboxylate ion. So let me show you what I mean. This is a carboxylic acid called methanoic acid. Methanoic acid. Right. But if you take the H off, it becomes a C double bond O, and the oxygen where the H was turns into a negative charge because hydrogen's gone. So this is called you take off oic acid and you put O8. So this turns into methan O8. Really, Harbin? You squished it on there? Okay. But this just happens to be our first example anyway. We used to have a hydrogen right here, but a hydrogen's gone, and so is the acid part of the name, and it turns into O8. So, it looks like an acid, but oh wait, the hydrogen's gone. So we call it methanoate. Okay, now, that is IUPAC. This is one of the ones you have to know the common name for too, and so then there's the common name. It's formate. It's the formate ion. This one you might be even more familiar with. Who wrote all over there? Come on. Seriously, messing up my slides, like I'll say, or messing up my slides. Okay. So this used to be ethanoic acid. Oh, wait, the hydrogen is gone. So now it's an O8. So it's ethanoate. 2-carbon carboxylate ion. Now, what will we call that using the common nomenclature? Acetate. So you might remember this from memorizing C2H3O2 negative acetate. Well, this is it, but this shows how it's bonded, and you can see now that this is an organic carboxylate ion. It's an organic ion. Okay. All right. What about this one? This you only have to know IUPAC. It looks like a carboxylic acid, but oh wait, the hydrogen's gone. Oh wait, get it? Propanoate. This looks like a carboxylic acid, but oh wait, the hydrogen's gone. I might stop it, might not. Butanoate. All right, so carboxylate ions are when there's nothing on the not double bonded O, and it's just got a negative charge. And so you just call it, oh wait, it's not an acid anymore because the hydrogen's gone, so you got to call it an O8. Now, esters. So what's the difference between an acid, an ester, and a carboxylate ion? Well, acids are COOHs. Esters are COORs. And carboxylates are O- where there's no R. So now we have this extra R where the H used to be. Used to be an H, COOH. Oh wait, the hydrogen's gone, and instead we have a carbon chain. Okay, so remember R, some kind of carbony branch, carbon-like branch. Okay, it's not carbon-like, it has carbons in it. Okay, so here's a general structure for it, and you can see the O8 part and the R part. The R is hanging off the single bond O. So we're going to still name this O8, but first we have to name the branchy part. So branchy part comes first. Name this first. All right, so if it's a 1 carbon, it's a methyl. If it's 2 carbons, it's an ethyl, etc. So you name it as a branch. And then O8, you name the rest. So, all right, so both the IUPAC and the common names of esters come from the parent carboxylic acid, but you lose the H, so you have the O8 part. And then you name the R prime as an alkyl branch first, followed by the name of the carboxylate ion. So let's look at this. Let's find the R. COO. Here it is. It's the R. R prime. What's the name of the R prime? Ethyl. That's what comes first in the name. This is an ethyl. Ethyl what? Oh, wait, there's more. 2 carbons, ethane. Ethane O8. All right, so the name of this ester. This is an ester, and its name is ethyl ethanoate. This one has a common name. This could be called ethyl acetate too. So IUPAC is ethyl ethanoate. Let me get this out of the way so you can see. There you go. And then the common name is ethyl acetate. All right, let's play some more. All right, so you look at it and you say to yourself, self, what the heck is this? And you're like, COO. Okay, there's something on the O, so it's not an ion. COO, it's not an H. What is this? This is an R. So this is an ethyl again. Ethyl. But oh wait, there's more. Ethyl methanoate. This one does have a common name. Ethyl formate is common because it's a 1 carbon base name, formate. All right, check it out. What is it? C double bond O O R. Are you sure there's something there? You bet. R. This time our R is called a methyl. And then our, but oh wait, there's more. 1, 2, 3. Propanoate. Methyl propanoate. So are you sure you go first? Yes. Are you sure you go first? All right. Whoop. C double bond O O R. Box the R. R is a propyl this time. Propyl. Whoa. Can you even read that? I'll say it again. I'll write it again. Propyl. So we have a propyl, but oh wait, don't forget the end. 1, 2, 3, 4, butanoate. Propyl butanoate. Okay. All right. So we've learned 3 things to name. And then we'll practice some more. Looking at it. C double bond O O R. R. Are you sure? Yes, I'm sure that's an ethyl. So where does it go? Are you first? Yes, I am. But wait. Oh, wait. There's the end. 1, 2, 3, 4. 1, 2, 3. So methyl here. So it's ethyl. 1, 2, 3 methyl butanoate. Ethyl 3 methyl butanoate. So for all of these, Stop the slideshow, stop it, and then see what you would name it, and then check. All right, what do we got here? We've got COOR. What kind of R are you? Are you a methyl? Yes, I am. So it's a methyl. 1, 2, 3, 4, 5. A methyl penta something, penta something. But oh wait, there's more. Ooh, double bond. So this is an ene. All right, where on 2? So it's methyl 2-pentenoate. Methyl for the R. This is the O8, and there's the ene double bond. Okay, right now I'm going to take a little, no, maybe, I'll do it now. I want to show you that for all of these, we've had CO, and the O goes this way, and we either had an H, or we had an R, or we just had a negative charge, okay? But I want you to realize that it could also be C double bond O, OH, right? So here's our H. Or we can have a C double bond O, OR. So it could go this way as well. What you're looking for to decide if it's an acid, an ester, or just a carboxylate ion is not the C double bond OO, but the single bond O, what's on there. Okay, you'll see it on the practice. What is this? COOR. Are you sure? Yes, I'm sure that's a propyl. It's a propyl, it's a propyl. What comes first? The R comes first, propyl, when you name it. But oh wait, there's more. This time it's benzoate, propyl benzoate. All right, a couple more. COOR. And look, you don't even see any C's, but it's out of the corner, so you have to be able to recognize it in line formula. Here's a methyl. This is my R. Are you a methyl? Yes, I am. 1, 2, 3, 4. This is a 3. So it's a methyl for the R. There's a methyl on carbon 3 on our butanoate. All right, let's check this one. R equals ethyl. 1, 2, 3, 4. Ethyl butanoate. Okay, let's check, are those right? Methyl, here's the answers. These we're not going to worry about. Okay, so we had methyl 3 methyl butanoate and ethyl butanoate. Okay, what about these ones? ROOR. Are you sure there's an ethyl? Yes. Remember, name your R first. Are you sure R comes first? Yes. And then this is benzoate. So this is ethyl benzoate. Benzoate's a common one, but you should recognize it. This one's tricky. ROOR. R. What is this R? Are you thinking about it? Are you thinking about it? Are you thinking phenyl? Good. 1, 2. So this is, but wait, there's an ethanoate, so it's phenyl ethanoate. Now for this one, common name would be phenyl acetate. Phenyl acetate. All right. I think that about sums it up. Peace out. Take care. See you soon.